Hi everyone, I hope you're okay. I'll be doing question number 3, guys, from the IEP examination. Please note that there is already one video uploaded whereby I tackled both question 1 and 2. Just click the link on the description below. It will take you to the playlist with the full memorandum. You can just download the question paper as well, and answer the questions with me. The question paper is the 2022 November examination, which was written by the IEP learners. Okay. Before we start, guys, please, guys, don't forget to like, share, and subscribe, and do comment, guys, if there are things you are not sure about. Né? Okay. Using first principle, find the derivative of g of x if g of x is equal to negative 3x squared. Okay. From first principle, né? G prime of x will be equal to limit as h approaches 0 of g of x plus h minus g of x all over h. Né? The aim here, guys, is to just substitute 0 whenever you see h. But in this case, we cannot do that because we have an h at the denominator. When we substitute 0 at the denominator, the entire thing will be undefined. Are you together? So the aim is to eliminate the h at the denominator first and then substitute 0 whenever we come across h. Okay, I'll simply have lim as h approaches 0. For g of x plus h, all I need to do is to substitute x plus h on the equation of g whenever I see x. I'll simply have 3. Whenever I see x, I'll say x plus h minus g of x. Né? G of x is equal to negative 3x squared. Okay, this is equal to the limit as h approaches 0. Obviously, whenever you expand the bracket, you obviously open two brackets and then expand the brackets, but you will end up having negative 3x squared minus 6xh minus 3h squared plus 3x squared all over h. This is limit as h approaches 0. The 3x squareds will subtract one another, and then we will be left with negative 6xh minus 3h squared all over h. Limit as h approaches 0. Can take out a common factor of h. You'll be left with negative 6x minus 3h all over h. Né? Limit as h approaches 0, we'll have negative 6x minus 3h. And then now we can substitute 0 whenever we come across h. Why? Because we no longer have h at the denominator. Are you together? So therefore, please note that whenever I substitute 0, whenever I see h, I no longer write limit as h approaches 0. I'll simply say 6x minus 3 times 0. So therefore, my derivative of g is simply negative 6x. That's how I would have tackled the derivative by using first principle. Okay, second question. I'm supposed to find f prime of x if f of x is this. Né? Okay, for me to find the derivative, there are things I don't need. Firstly, I don't want to have brackets. Luckily, I don't have brackets here. I don't want to have surds. I do have surds. That means I must remove the surds. And I don't want the variable I'm supposed to derive to be at the denominator. That means I must remove the variable at the denominator. Okay. How can I do so? Firstly, I have I know f of x is equal to this. Now, for me to remove a number from a term rather from the denominator to the numerator, all I need to do is to change its exponent. I'm just going to apply this exponential rule that whenever I have 1 over a to the power p, this can be written as a to the power negative p, right? So in here I can simply have 5 over 3 multiplied by x to the power negative 1 plus please guys note that if I have a, x and b, the root of a number is always the denominator of an exponent. Are you together? So in this case I'll have x is equal to x to the power 5 over 3, like that, né? So therefore the derivative, now I can find my derivative, right? I will only write f prime of x if the statement after the equal sign is my derivative. If I'm not yet deriving, I will never write f prime of x. Are you together? So f prime of x is simply negative 5 over 3x to the power negative 2 plus 5 over 3x to the power 2 over 3. Which rule am I using? I'm using the power rule that if f of x is equal to a multiplied by x to the power n, therefore my derivative, I'll just take the exponent and multiply with the coefficient. I'll have n multiplied by a, and then I'll just subtract 1 on at the exponent. Are we together? So that's my derivative. If I want to, I can leave it in positive exponents. Let me write in blue because I can just leave my answer here. What I'm doing here is not necessary, but sometimes they stipulate that please leave your answer in positive exponents. So we'll simply have 5 all over 3 times x squared plus 5 over 3. You can even write this one as a root as well. We'll have x squared, cube root of x squared. You can leave your answer like this or just leave it like this. It's up to you. Okay, now let's move to C. In the diagram below, f of x is equal to x squared minus 2x minus 3. A is the y-intercept and b is the x-intercept of f. Calculate the coordinates of a and b. The y-intercept is given by the constant there in the equation. So I know that the coordinates of a, x is 0, y is negative 3, right? All I need to do is to find the coordinates of b. How can I find the coordinates of b? I know that x is 0 at the x-axis because b is an x-intercept, right? So y is 0 at the x-axis. All I need to do is to solve for x. So if y is 0, let me write like this. For me to solve x, I know that f of x needs to be equal to 0, but f of x is equal to x squared minus 2x minus 3. That's equal to 0. I'm supposed to factorize here. I need the factors of x, or factors of 3 rather. That's when I subtract will give me 2. That's 3 and 1. Obviously the bigger factor will take the sign of the middle term, minus and plus, then x is equal to 3 or x is negative 1. Okay, so therefore the coordinates of b, let me write them there at the top in green. The coordinates of b, I have 3 and 0. Okay, I'm supposed to determine the coordinates of the point on f of x where the tangent to the curve f is parallel to line AB. Okay, I want to find the coordinates of the tangents. The coordinate of the point of contact of the tangent and the curve, and that tangent will have a gradient which is parallel. That tangent rather is parallel to the line AB, which means the tangent has a gradient which is equal to the gradient of line AB. Okay, let's first find the gradient of line AB. MAB is equal to y2 minus y1 over x2 minus x1, right? I can take A as my y2, so I'll have negative 3 minus 0 all over 0 minus 3. So this is equal to negative 3 over negative 3. That's just equal to 1. So the gradient of line AP is equal to 1, right? Okay. They want me to find the coordinates of the tangent which has a gradient which is equal to 1. Okay. F of x is equal to x squared minus 2x minus 3. Okay. F prime of x is equal to 2x minus 2. Are you together? I want to know the x value whenever the gradient is equal to 1. So where I see f prime of x, I'll just substitute a 1 because f prime of x represents the gradient of a tangent to the curve. Whenever I bring the 2 to the other side, it will be positive. I'll end up having 3 is equal to 2x. Then x is just equal to 3 over 2. Therefore, all I need to do is to go and find the corresponding y value. F of 3 over 2 is equal to 3 over 2 squared minus 2 times 3 over 2 minus 3. What does this give me? 3 over 2 squared minus 2 times 3 over 2 minus 3. The corresponding y value is negative 15 over 4. So the coordinates of the tangent of f that has of which the tangent is parallel to the line AB, it has the coordinates of 3 over 2 and negative 15 over 4. That's how, guys. That's how you could have tackled question 3. Is it question 3? Yeah, question 3. No? Just do comment, guys, if there are things you're not sure about. If you are happy, just hit the thumbs up, share and subscribe, guys. Thank you for your time.